Right. Our next topic is binomial expansion. Binomial expansion. This is chapter 3 in C4, right? When we took binomial expansion in the AS, we took two rules for the binomial expansion. We took one rule. It says A plus B to the power n equal A power n plus n1 A power n minus 1b plus n2 A power n minus 2b2 and so on. And we are given in the formula sheet another interesting rule. Says 1 plus x to the power n. This is equal to 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 x cubed over 3 factorial and so on. The second rule, we use it if the first term was 1. If the first term is 1, we use the second rule. For example, if we were asked to find 1 right plus x to the power 5, then using the rule we are going to say 1 plus 5x plus 5 times 4 over 2 factorial x squared plus 5 times 4 times 3 over 3 factorial x cubed plus 5 times 4 times 3 times 2 right over 4 factorial x power 4 plus 5 times 4 times 3 times 2 times 1 over 5 factorial x power 5. If we continue, then all the remaining terms will be 0. This indicates that this expansion stops at x power 5. And if we simplify this, we will get exactly the proper expansion, or exactly the exact expansion of 1 plus x power 5. But our question is this: what will happen if I ask you, let us get the value of 1 plus x to the power half? Then we apply the rule 1 plus half x plus half times negative half over 2 factorial x squared plus half times negative half times negative 3 over 2 over 3 factorial x cubed plus, and we continue. This expansion, it will never end. What means it will never end? I can keep writing terms and terms and terms and terms, and the power of x getting higher and higher and higher and so on. If we simplify this expansion, we get 1 plus half x minus 1 over 8 x squared plus, we are going to get, right, 2, 2, 2, okay, 3 factorial is another 2, and 1 over 16 x cubed. If we try to use this, right, to calculate and if we substitute the value of x, any fraction, say if we put x equal 0.01 and we calculate this and we get this expansion, we'll find this gives us almost the correct solution. Why? We can say this: if we are going to stop after some numbers, this means that the remaining terms will be of negligible value. When will the remaining terms will be of negligible value? If the value of x is less than 1, because it is known that if x is less than 1, then x to higher power is much, much smaller and can be neglected. And therefore, we can say that this expansion is true only if the value of x or modulus x is less than 1. Because x cannot be minus 2. Because again, minus 2 to the power 4 is a very large number. And therefore, we say we want x to be between -1 and 1. This means modulus x less than 1. So if modulus x less than 1, we can say this expansion will be almost true. All our problems in the A level will be of this kind. All our problems will be how to expand 1 plus x or 1 plus 2x or 1 plus something in terms of x to a power which either that power is a fraction or that power is negative. Because in this case, we cannot use the above expansion. Therefore, I'm going to use a new expansion the rule, the common rule, but we are going to use the new philosophy that we write few terms and we stop. Why? Because the remaining terms are negligible. Let us have another example. If, for example, we were asked to expand one we want to expand one, right, 1 over one over 1 plus x means 1 plus x to the power negative 1. We apply the rule which is given in the formula sheet. 1 plus nx, n times x, plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial, right, x cubed. You always be asked to write the expansion up to x cubed, and this would be equal to 1 minus x plus x squared minus x cubed. And this expansion is true again for the value of x is modulus x less than 1. Another example, we can be asked to find the expansion of the square root of 1 minus 3x. Then we say this is 1 minus 3x power half. This would be equal to 1 plus n is half, if x is minus 3x, plus half times negative half over 2 factorial negative 3x squared plus half times negative half times negative 3 over 2 over 3 factorial negative 3x cubed. As I said, we always be asked up to x cubed. 1 minus 3 over 2x if we simplify the terms. Right. Minus 9 over 8x squared minus 27 over 16x cubed, and so on. This is valid for x, which is modulus 3x less than 1, which means modulus x less than 1/3. We can have so many examples, right? We wanted to expand, for example, right, the cube root, of 1 minus x, which means 1 minus x to the power 1 over 3. This would be equal to 1 plus 1 over 3 times minus x plus 1 over 3 times negative 2 over 3 over 2 factorial negative x squared plus 1 over 3 times negative 2 over 3 times negative 5 over 3 over 3 factorial minus x cubed. If we simplify, we get 1 minus 1 over 3x minus 1 over 9x squared minus 5 over 81 x cubed. Therefore, we say this rule of 1 plus x to the power n can help us to find the expansion of any expansion, 1 plus or 1 minus to any power. If we wanted to expand 1 over 1 plus 4x squared, means 1 plus 4x to the power negative 2. This would be equal to 1 plus negative 2 times 4x plus negative 2 times negative 3 over 2 factorial 4x squared plus negative 2 times negative 3 times negative 4 over 4 factorial over 3 factorial 4x cubed plus and so on. This is equal to 1 minus 8x plus 48x squared minus 256x cubed and so on. This is true when modulus 4x less than 1 means modulus x less than 1 over 4. Now, let us have a question, very interesting example. It says we want to get the expansion of the square root of 1 minus 2x, which means 1 minus 2x to the power half. This would be equal to 1 plus half negative 2x plus half times negative half over 2 factorial negative 2x squared negative 2x squared plus half times negative half times negative 3 over 2 over 3 factorial negative 2x cubed. If we simplify this, right, expansion, we got 1 minus x squared over 2 minus x cubed over 3. Right? Then it is given to us in the question to substitute the value of x equal 0.01. If we substitute x equal 0.01 in both sides. Then the left hand side would be the square root of 1 minus 2 times 0.01. On the right hand side would be 1 minus 0.01 minus 0.01 square over 2 minus 0.01 cube over 3. This would be the square root of 0.98. And this would be equal to, right, 0.9899495. The square root of 0.98 means the square root of 98 over 100, equal to the decimal we had, to a 0.9899 and so on. 0.98 of this means 7 root 2 over 10 equal 0.9899495. This means root 2 equal 10 over 7 times 0.9899495. And if you can use calculator to get this, we'll get 1.414213571. This is, by the way, is an exact value of root 2. Right. In the question it says find a suitable value of root 2. Therefore, we can make use of this binomial expansion by substituting x some values to calculate certain values. Right. This expansion, which is the square root of 1 minus 2x, we can get the value of the square root of 98. And that's the question, it will be like this. And we'll get the exact value of the square root of 98, which is 0.98, and means 98, which means 10 times that answer. And the square root of 98 will be 9.8994. Sometimes we have questions like this, that we will be asked, be given some values of x, hence you can use it to calculate certain values of certain numbers. Sometimes it will not be given to us what number to substitute, and he will tell us to substitute a suitable value in order of x, right, in order to calculate something. We will have questions like this later on. Now, we will come to another problem. What is it? How can we get the expansion of, for example, 4 plus x to the power half? This is not 1 plus x. We can only use the rule, as we see in the previous problem, only if the first term is 1. We can only use the rule 1 plus x. And therefore, we cannot use the rule now. But we are going to do something. We'll try to make the first term 1. How? By doing this. By saying that this is equal 4, common factor, our factor, 1 plus x over 4, This is all to the power half. Therefore, it will be 4 power half times 1 plus x over 4 power half. And 4 power half is 2. Then we make the expansion of this. Then we multiply the answer finally by 2. We expand this, and this expansion would be 1 plus half x over 4 plus half times negative half over 2 factorial x over 4 square plus half times negative half times negative 3 over 2 over 3 factorial x over 4 cube. Then this would be 2 outside. We simplify the inside. The inside will be 1 plus x over 8, right, minus x square over 128 plus x cube over 1024, multiply by 2, you get 2 plus x over 4 minus x square over 64 plus x cube over 512. And when this expansion is true, we go back to the expansion of 1 plus. This means when modulus x over 4 less than 1, which means modulus x less than 4. Therefore, we are able to expand, to make expansion, even if the first term is not 1. Right? Let us have another problem. Now, we have 1 over 2 plus 3x square. This is going to be equal to 2 plus 3x or negative 2. The 2 will go outside, will take power negative 2. Then it will be 1 plus 3 over 2x power negative 2. 2 power negative 2 means 1 over 4. And we make this expansion. This expansion 1 plus n times x plus n times n minus 1 over 2 factorial times x square times n minus 1 times n minus 2 over 3 factorial times 3 over 2x cubed. We simplify this, we get 1 over 4 bracket into 1 minus 3x plus 27 over 4x squared minus 27 over 2x cubed. Multiply times 1 over 4, give a 1 over 4 minus 3 over 4 x plus 27 over 16 x squared minus 27 over 8 x cubed. When is this condition is expansion is true? When 3 over 2x modulus 3 over 2x less than 1, which means modulus x less than 2 over 3. Next, you remember we had before problems of partial fraction. Now, we will be given something like this partial fraction. Say express 4 over 4 minus 5x over 1 plus x p2 minus x. We are going to say this is equal to a over 1 plus x plus b over 2 minus x. Then the method of partial fraction, we multiply times the denominator. Therefore, we get 4 minus 5x equal a times x2 minus x plus b times 1 plus x. We substitute values. We put the value of x equal -1. Therefore, we get 9 equal 3a, a equals 3, and we put x equal 2. Therefore, we get -6 equal 3b. Therefore, b equal -2. Therefore, 4 minus 5x over 1 plus x 2 minus x is equal to 3 over 1 plus x minus 2 over 2 minus x. This would be equal to 3 times 1 plus x minus 2 over, we took 2 common factor, we got 1 minus x over 2. That means 3 over 1 plus x minus 2 over 1 minus x over 2. We are going to say this is equal 3 times 1 plus x or -1 minus 2 into 1 minus x over 2 or -1. This would be equal to 3 times 1 plus -1 times x plus -1 times -2 over 2 factorial x squared plus -1 times -2 times -3 over 3 factorial times x cubed. Then we have minus 2 outside, right? The 2 will cancel with 2. This will be 1. This will be 1 because the 2 will cancel with 2. Minus 1. This 2 will cancel with this 2. 1 open bracket. We have 1 plus -1 في negative x over 2 plus -1 في -2 على 2 factorial -2 square plus -1 -2 -3 over 3 factorial into -x over 2 cube, right? X over 2 square. This will be equal to 3 open bracket into the expansion will be 1 minus x plus x squared minus x cubed. And the other expansion minus 1 into, which will be 1 plus x over 2 plus x squared over 4 plus x cubed over 8. This would be equal to the first bracket we multiply, we get 3 minus 3x plus 3x squared minus 3x cubed. And the second bracket will be plus, right, 1 plus, right, it will be minus outside, okay, plus 1 plus x over 2 plus x squared over 4 plus x cubed over 8. Now we calculate 3 minus 1 is 2, negative 3 and negative 3 over 2 together, right, this gives us negative 7 over 2x, and then you get us 11 over 4x squared, and will give us minus 25 over 8x cubed. What is the condition for the first expansion to be true? The first expansion to be true is that modulus x less than 1, and the second expansion modulus x over 2 less than 1. This means x between negative 1 and 1. This means x between negative 2 and 2. In the number line, we have 0, 1, 2, negative 1, negative 2. One expansion is from this to this. The other expansion is from this to this. What is the common region? That x is between negative 1 and 1. And this is the condition for the expansion, for the whole expansion to be true. Either like this or saying modulus x is less than 1. This is and this means that in sometimes you are being asked partial fraction, and then after partial fraction, binomial expansion of the terms you get after partial fraction, because all the terms you are going to make them, the bottom will go up or negative 1, and then you write the expansion, then you simplify the total expansion into one expansion. And this is a typical examination question. This is the end of this topic.